Here we're going to be learning about solving quadratic equations by taking the square root of both sides of the equation. We're going to look at the steps that are involved in solving quadratic equations by taking square roots, and then we will look at some examples together just so we can demonstrate how to apply these steps. So if we are looking at solving quadratic equations by taking square roots, we want to check for what type of equation we have. If we have something that is represented as the difference of two squares, and what I mean by that is something like x squared minus 9 equal to 0, or 4x squared minus 49 equal to 0, something that looks like this, we will make sure we rearrange the equation so that the variables and constants are on opposite sides. And then we will express both sides of the equations as perfect squares if they are not difference of two squares. Then after that, we'll take the square root of both sides and make sure to have the plus or minus before the constant, which stands alone on one side of the equation. And then we will go ahead and solve the equation by isolating the variable. So let's see what all of this stuff we've discussed. Let's see what they mean and how to apply them to actual examples. So here we have, this is an example of a difference of two squares. So what we're saying here is the first thing we're going to do is make all the variables on one side and the constant term on the opposite side. So let's go ahead and add 25 to both sides here. So we have x squared equal to 25. Now we're saying that after we've done this, we're going to find the square root. We're going to take the square root of both sides, but remember to put a plus minus on just before the square root for the constant term. So when I say constant term, it just means a number that does not have a variable attached to it. So when we find the square root of x squared, we have x equal to plus or minus the square root of 25 is 5. So what this means is x equal to 5, also x equal to negative 5. The next example that we have 2x minus 3 squared minus 16 equal to 0. So what we're going to do is we're going to keep the expression on one side and the constant term on the opposite side. So let's go ahead and add 16 to both sides. So we have 2x minus 3 squared equal to 16. So the next thing we're going to do is we're going to take the square root of both sides. So we take the square root here, we take the square root here, and remember to add a plus minus here. So we now have 2x minus 3 equal to plus or minus 4. So this simply means 2x minus 3 equal to plus 4. We also have 2x minus 3 equal to negative 4. So let's go ahead here and add 3 to both sides. 2x equal to 7. We divide by 2. And we have x equal to 7 over 2. So we add 3 here as well. And we have 2x equal to negative 1. We divide by 2. And we have x equal to negative 1 over 2. So therefore, x is equal to negative 1 over 2 or 7 over 2. And then finally, we have solved x squared plus 4x plus 4 equal to 64. So let's try to see if we can create a perfect square here. So this is going to be, if we actually solve this as an expression on the left-hand side, we're going to have x plus 2 multiplied by x plus 2, which is equal to 64. So this can be rewritten as x plus 2 squared equal to 64. So now we can take the square root of both sides, and remember to have a plus minus here. So therefore, x plus 2 equal to plus or minus 8. So then we're going to create two equations. X plus 2 equal to 8. We also have x plus 2 equal to negative 8. Here, we subtract 2 from both sides. X equal to 6. Subtract 2 from both sides. x equal to negative 10. So therefore, our values are x equal to negative 10 or 6.